When Copilot code review tries to contact a destination the firewall does not allow, GitHub blocks the request. Then it places a warning in the pull request showing the blocked address and the command that tried to reach it. The reviewer keeps working. The request does not leave. That matters because the reviewer is examining material another person wants merged into your repository. It may read changed code surrounding files, documentation, configuration, and instructions. If any of that content can redirect the agent, an outbound connection can become an exit path for repository context. This is not a disclosed Copilot breach, and it is not our penetration test. It is the threat model in GitHub's own documentation. GitHub says unexpected agent behavior or malicious instructions could leak code or sensitive information to remote locations. On July 17th, it made the network boundary default. Copilot code review no longer reads only the diff. It now uses tools inside a GitHub Actions runner to gather broader repository context around the change. A pull request changes one function. The reviewer follows an import into another module, searches for references, opens a configuration file, and runs a command to understand the project. That exploration can produce better reviews. It also means untrusted content and tool access now occupy the same runtime. The same release changed where review guidance comes from. Copilot code review now reads custom instructions, agent skills, and agents.md from the pull request's head branch. That makes instructions easier to test before merging. It also means the branch under review supplies part of the reviewer's context. Reading head branch guidance is not automatically a vulnerability. The reviewer needs repository-specific rules. But it creates a clear trust boundary. A contributor can change the code and the instructions describing how that code should be reviewed. Security cannot depend on every instruction being honest. Here is the threat path, reconstructed from the documented controls. A pull request contains a legitimate-looking patch and an instruction that encourages the reviewer to validate something through an external service. The code can be harmless. The dangerous payload is language the agent may treat as part of its job. The reviewer sees the patch, then gathers the repository guidance available to that review. Human-readable documentation and agent-readable instructions are both text. The model must decide which text explains the project and which text is trying to redirect its behavior. That is the prompt injection problem. As the review continues, its working context becomes more valuable. It may include source code, tests, configuration, file names, architectural relationships, and the output of local commands. The threat is not that the model knows one secret. It is that a manipulated tool call can package whatever context is available. The injected instruction does not need to make the reviewer praise bad code. It can ask the agent to run a command. That command can encode a fragment of context inside a URL or request body and contact an attacker-controlled host. The final review comment could still look completely normal. The firewall does not have to solve prompt injection. It does not need to understand whether the model was confused, maliciously instructed, or simply wrong. It evaluates the network destination. If the address is outside the allowed policy, the process cannot establish the connection. GitHub also makes the failure visible. For a new pull request, it adds the warning to the pull request body. For an existing one, it adds a comment. The warning contains the blocked address and command, turning silent network behavior into something a maintainer can investigate. This is why the defense sits below the model. Prompt rules ask an agent to recognize hostile instructions while reasoning through them. Network policy limits the consequence after recognition fails. Independent agent research also finds system and network controls more durable than output checks alone. Capability matters more than confidence. But the default is not a sealed room. GitHub's recommended Allowlist keeps common operating system repositories, language package registries, container registries, certificate authorities, and certain browser download hosts reachable. Reviews need dependencies and tools. Every allowed destination is a usability decision and part of the remaining attack surface. The first major gap is process ownership. GitHub says the firewall covers processes. The agent starts through its bash tool inside the Actions appliance. It does not cover processes launched by configured setup steps. A network boundary around one execution lane does not automatically protect every process in the environment. The second gap is tool architecture. The firewall does not apply to Model Context Protocol servers. GitHub's OwnMCP server and Playwright MCP server can be available to code review, and organizations may configure others. Those tools need their own permissions, network rules, and data controls. GitHub is unusually direct about the boundary. Its documentation warns that sophisticated attacks may bypass the firewall and says the control should not be treated as a comprehensive security solution. This is not a prompt injection cure. It is one containment layer for common agent-started network requests. The largest operational exception is self-hosting. GitHub says self-hosted runners do not currently support this built-in firewall. Those reviews continue without it. GitHub tells operators to configure their own network controls and avoid giving the review runner open access to an internal network or the public internet. Independent research strengthens the category-level threat without proving a Copilot incident. GitInject tested live AI-powered GitHub workflows across multiple providers and documented attacks involving configuration injection, credential exfiltration, judgment manipulation, and availability. Its central result was structural, workflow permissions, and configuration can matter more than model identity. Another independent study showed why the final response is a weak security signal. In its local agent testbed, malicious external content triggered outbound leakage while the answer shown to the user appeared harmless. The lesson is simple. Review what the agent can transmit, not only what it says. GitHub also separated code review from the Copilot cloud agent at the administration layer. Organizations and repositories can control the review firewall independently, and organization runner settings now have distinct sections for the two agents. A reviewer and a coding agent no longer need the same network or compute policy. Teams can also create a dedicated Copilot code review.yml file. It can install dependencies, select tooling, and configure a repository-level runner separately from the cloud agent. If that file is absent, code review falls back to the existing shared setup file. Separation makes the trust boundary auditable. The first practical move is boring and effective. Keep the firewall enabled. Review the recommended allow list instead of assuming default means minimal. Add custom destinations only when the review genuinely needs them, and scope URL rules to the narrowest scheme, host, and path the workflow can use. Then audit the lanes outside the built-in boundary. Treat setup steps as code execution. Review every MCP server and its permissions. Isolate self-hosted runners and restrict their egress. Minimize variables and secrets available to the environment. A firewall around Bash cannot compensate for a privileged tool beside it. When the warning appears, do not treat it as harmless noise. Inspect the destination, command, pull request files, instruction changes, and review session logs. GitHub exposes which MCP context and tools participated in a review. The block is both protection and an incident signal. There is one final boundary outside the runner. Copilot code review leaves a comment, not an approval or request for changes, and its review does not satisfy required approvals. Human review, branch protection, secret scanning, and ordinary workflow security still decide what crosses into the repository. GitHub did not make AI code review trustworthy by teaching a model to ignore every malicious instruction. It put a wall around what the reviewer can reach after the model makes a mistake. That is the real lesson. Do not secure an agent only at the prompt. Secure its capabilities, exits, and authority.